Greetings and welcome to my new calculus channel. My name is John Gabriel. So today I'm going to do a little revision of questions that I didn't actually handle in the last video, which are not kind of important, which are actually important. So these questions concern some details that were not possible to fill in then because I was in a little bit of a hurry. But anyway, let's cut a long story short. Let's begin. So in the last video, I talked about, this was the video before the last one, an easy proof that pi is a constant, and that was really successful, over 1,000 views in 2 days. I'm glad about that. And I revealed some really groundbreaking facts about constants. And of course, in the latest video, which is the one on constants, you'll remember this applet that I used, which dealt with the four famous constants: pi, square root 2, the golden phi, which is realized from the golden ratio, and e. So what do all these constants have in common? Well, like any other number, they are related to measure. Okay, in other words, they are realized from measure, the act of measure. So for example, remember I showed you that the ancient Greeks, when they defined number, were using ratios, okay? And before number, all they had was geometric arithmetic, okay? So you'll find in this article here, this fantastic article, by the way, which Euclid should have been spanked because he didn't write this down. Well, that's kind of silly, but anyway, this method is so important since everything that you understand about, or that you know rote fashion about numbers and arithmetic, comes from arithmetic with ratios. And I'll show you how all the four basic operations work. Okay, so this is a free book, and in the not too distant future, another video is going to come out explaining all these four operations, basic operations. And it contains a beautiful applet, which will show you in one go how to do all these things. And these are things that Euclid should have written down. They were important, but he didn't. And so how did I realize these things? Well, because I studied the elements and I understood them, unlike the morons of the last, 400, 500 years who were trying desperately to understand the elements and failed miserably. So this knowledge it's not only groundbreaking, it's essential for any mathematician, any real mathematician to understand. You cannot even begin to think of yourself as a mathematician's backside unless you understand these things, okay? Because these things are so basic to the most foundational concept, which is number. And of course, mainstream mathematics, which is based on the crap of axioms, which are beliefs, really. They're not sound facts, they're beliefs. And infinity, of course, is the big fly in the ointment. That's the reason that mainstream mathematics is a load of rubbish, okay? Because it's based on axioms and set theory. And set theory is, unfortunately, one of the problems with mainstream mathematics and ZFC axioms. So when we do something like, when we write something like 3/2, it comes from a measure of these line segments. In other words, we could do it two ways. We could take this blue line segment and say, okay, look, you can say it measures this guy once and then a half, okay? 1.5 times it measures it. Or we can find a common divisor of both of them. And a common divisor of both of them is, for example, this section here, right? That's a common divisor. So that is a way we can measure a ratio. And then we say, all right, well, the antecedent is enumerated to 3 and the consequent to 2 using this as a unit of measure. And likewise, when we deal with these constants, pi, square root 2, etc., that's also what we're doing. So look, let's get rid of that. The constant pi is realized when we take the diameter of a circle and we try to measure the circumference. Okay, so again, let's get a pen. Here's a pen. So if we have this as the diameter, then it measures the circumference 1, 2, 3, and a little bit. Okay, we don't know this little bit. We can make it more precise with many techniques. We could use approximations in the form of polygons, in the form of series, etc. But we can also prove that this ratio here has no measure in terms of the abstract unit. By the way, when we realize number, we're using the abstract unit. This here acts as an abstract unit. The consequent, okay, becomes the abstract unit. The same thing happens when we look at let's see, square root 2. We're trying to measure this diagonal with the side. Okay, so it's approximately 1. It's approximately 1. And this little bit here, right? So similarly, same thing happens with E, okay, and all the others. So if we have this distance here, it's measured by this distance here. Likewise, if we increase the distance and now try to measure this distance with this distance, okay, so let's get a pen. So again, we're still going to get E. It doesn't matter what unit we use because this acts as an abstract unit. So this is 1, 2, and approximately 0.718 here, okay, 0.718. So this is what number is all about. It's all about measure, okay? It's all about measure. You can't have number without measure. That's the first thing that comes up. So now I hope I've made that perfectly clear. So the constants are realized when we attempt to measure immeasurable ratios, such as these ratios that I've just shown here. Constant pi is realized from this ratio, CD, and this one from diagonal side, this one from a sum of the hypotenuse and the unit. This is the so-called golden ratio. Sum of the hypotenuse and the unit measured by the unit. The unit doesn't have to be 2. It can be 1. Okay, it can be 1. There you go. That's approximately 1. You'll still have the same measure. It doesn't matter what it is. It will always be the same measure. Okay, so this hypotenuse is not phi, as you've mistakenly been taught. Okay, so for example, if you have that, your idiot mathematics teacher or calculus teacher will tell you that this here is square root 5. Absolute rubbish. It's not. The measure of this hypotenuse using this ratio, hypotenuse plus unit, which is represented by this, measured by just the unit, whatever it is, gives you the golden ratio. Okay? So that's how you get the constant phi. You attempt to measure the hypotenuse plus half of the unit by the actual unit. Right, so there is no such thing as an irrational number, by the way, and the ancient Greeks knew this. They were not flummoxed as so many PhD morons have written in long dissertations, which are full of worthless citations that make their dissertations appear scholarly because those citations are from other idiots. And they will only quote other idiots because they are idiots. And so the prize idiots of mainstream think that the Greeks were flummoxed. But the ancient Greeks gave you number and measure, and they knew about ratios that refused to be measured. Okay, they knew about those ratios. And how did they discover that those ratios couldn't be measured? That's right, they used algebra, because algebra uses the abstract unit. You stupid morons, listen. When you try to measure this golden ratio, you're using this as a unit. 1, and then this little section here, it's about 0.6 of this unit. Do you understand? You don't have to be stupid like your calculus professor or your math teacher. You can understand these things. Now, don't be fooled by the bullshit that they throw at you in real analysis courses. Things such as Dedekind cuts, Cauchy sequences, Eudox's reals, and the like. None of those are valid constructions of real number, and they have nothing to do with measure. So you can find out a lot more about that if you go to my academia site, where I've written hundreds of articles. I've written 281 papers. Okay. And I deal with that. So, for example, I've got an article called On Dedekind Cuts, and that explains to you why Dedekind cuts and Cauchy sequences do not constitute valid constructions of real number. There is no such thing as a real number. It's a garbage concept. And the only numbers we have ever used are those commonly known as rational numbers, with the adjective rational being redundant, because a number is by definition rational, and rational implies number. So, for example, when you say irrational number, you reveal that you're a moron, because that's like saying irrational rational. Does that make sense? Think about that, people. Don't be idiots. Listen to what I'm telling to you. What I'm telling you. I am smarter than you. Otherwise, I wouldn't have realized these things. Okay? It takes genius to realize these things. For thousands of years, you didn't know or understand the operations with fractions. You thought that multiplication by integers comes before division by integers, and you thought that the process for dealing with arithmetic with whole numbers is different to fractions. It's not. They're all exactly the same process. You just didn't understand because you weren't smart enough. And I'm trying to make you smart. So listen to what I'm telling you. I know better. Right. So before I sign off, there's some comments I want to deal with. So some idiot here posts that your entire premise depends on the idea that the Greeks were so enlightened that they must have been right about everything. And he says, the problem is with the axioms and arguments you deem are impermissible, which modern math is otherwise okay with. That's rubbish. Because, as I said, the ancient Greeks' ingenuity remains unmatched, but that doesn't mean they didn't make mistakes. And also, axioms are a load of rubbish, because belief has no place in mathematics. There's no such thing as modern math, only modern mythmatics. Okay, so that's one of the comments I had to deal with. And another one, coming back to this person here who commented about using an integral. So the problem with this person is that he or she has missed the point of the whole idea. The integral is a method of approximating the constant, but the key point lies in the idea that the constant is realized from a failed measure. Okay, that is, an attempt was made to measure an immeasurable ratio. That's how we get these constants. We try to measure immeasurable ratios like this. Okay? Do you understand that? Take some time to think about that. That's how you got number, and that's what number is. So also download this applet. It's a fantastic applet, and explains to you how all these things work. Okay, and you can actually see that when you try to measure the antecedent, which is a red line with the consequent, you end up with that constant, or something that resembles a constant. It's never a number in the terms of being a complete measure, because a number by definition is a name given to the measure that describes a ratio of magnitudes. Okay, and the ratio of magnitudes in this case is the ratio of this red line to the green line. That's what it's about. Right. So there is a fantastic book that you need to buy. It's called The Ultimate Book of Numbers. Okay. You can get a hard copy for $150 or just a Kindle for $10. And this is by far the best book ever written on numbers. It tells you everything you need to know about numbers. And then once you've studied that book, you'll be in position to understand the concepts of my latest work, which is this one here, and it's the importance of learning the right way. And it incorporates my learning theory called Catus. And so it explains to you what division means in mathematics and how it affects all other arithmetic concepts, and how basically the complexity that you have today was built in a very proper way. In other words, not using ill-formed concepts like infinity, calling zero a number which it's not, infinitesimals, and all the other rubbish that you find so plentiful in mainstream mathematics. So, if you're not already a subscriber, become a subscriber to my channel. Click like on my videos. I am doing this for humanity, by the way. To be frank with you, I've earned about $100 since I started this channel. And of course, I could have done something like that idiot Michael Penn and just given you mainstream mathematics, or like that idiot Professor Dave explains, or all the other idiots, Numberphile, etc., who have millions of subscribers and millions of views and earn a stinking amount of money every month. Let me tell you, somebody with 1 million subscribers can earn anywhere between $15,000 to $60,000 a month. Here I am, busting my butt, being called names, being called mentally ill, etc., giving you the truth. And you vote my videos down. You fucking morons. This doesn't only affect you, it affects your offspring, the extension of your stupid self. I have no children. I'm doing this for you and your children. Why don't you realize that? Study my work, you baboons. You'll figure out that I know better than you. And I'm not speaking to those who know I'm right already. I'm speaking to the rest of you morons out there, because you are morons. I don't care if you have a PhD. By the way, do not call yourself a mathematician if you have a PhD. You're not worthy to be called a mathematician asswap, okay? Because your essay, your PhD dissertation is not worth a roll of toilet paper. To be called a mathematician, you need to produce great works, like the new calculus, for example, or the works that I've been talking to you about, realizing all these wonderful facts about how we got number, where it came from, geometry, and the perfect ideas that one needs to become a real mathematician. So, also, you can join my Discord channel. It's not mine, really, it's run by somebody else, and find out a lot more about mathematics and calculus, especially. So, I encourage you to join the channel and also to become part of my members only by clicking join on my videos. It costs a mere €4.99 a month. Basically peanuts. It's a cup of coffee or a beverage that you'll buy at Starbucks or Costa Coffee or wherever. So that's pretty much it. I enjoyed talking with you in this video. I hope that you will realize that I'm not arrogant. I am proud. Yes, I'm very proud of my work. I am a great mathematician, probably the greatest mathematician today. If I compare myself to past academics, I'd say the one that comes close to me and maybe and probably exceeds me is Archimedes. Again, Archimedes is still my idol. Newton, no, not so much anymore, but Archimedes is still there. He's untouchable, by the way, really untouchable. And no other mathematician who came after him is even worthy to be called a mathematician in his class. So that's pretty much it. My name is John Gabriel. This is New Calculus Channel. Until next time, goodbye.